Okay, exercise number 7 on page 135 matches example 2 in 1.5 on page 128. And this is using the graphing calculator in parametric mode. So it comes from the same set of problems that exercise 5 came from, but this time we're going to use the calculator. So first we're going to start, you want to enter those equations in to your in parametric mode in your calculator. So go under mode, okay, go under mode, hit parametric, and then your y equals, and it should come up like this. And you can see that we have the first x equals t squared, and this is y equals t minus 2. And here's my x, and here's my y. Okay, so once you enter those things into your calculator, we'll be able to graph it and look at the table and everything. These pictures are also, not using this equation, but these pictures are also at the bottom of where that example 2 is on page 128. So after you might want to hit pause to put this in, but after you put this in, let me erase these things right here. After you put this in, the next thing you want to do is go to your table setup. Okay, and under table setup, the way you get there is you do second, the yellow button, which is right down here at the bottom of the picture, and window, because above window is the yellow table set. And we want to go from -3. We want to count by ones, and then the rest of this should be set to auto. Okay, so get that set up, and then we'll go to the third part here, which is your window, and make sure your window is set up correctly. So your window should be t minimum, the time minimum from -3 to +3. Those are the numbers that we're putting in for t, if you remember from exercise number 5. We want to count by 0.1, x minimum -10, x maximum +10, counting by ones. And then I just did the same for y minimum -10, y maximum 10. You're going to have to keep going down on this to see the rest of it on your calculator. I just have a picture right here. So set up your table, set up your window. What's the next thing it wants you to do? Okay, if you graph it, you're going to get kind of this parabola, but it's going to open up towards the x-axis here, right? Which obviously means it's not a function because it does not at all, right, match the vertical line test. It hits the function both here and here, which means it's actually not a function. It just hits the curve. We'll call that the curve in 2 spots, which means that this is not a function. What this question wants you to do is double check that it's not a function algebraically. So we'll check that in just a second. Let me show you. Let me grab the table here really quick, and you can, whoops, and you can make sure that you got the same table as I did. So instead of making that table on paper like we did the other one, we can make that table in your calculator, and you can see you should get the same answers back that you would get if you made the table by hand. Okay, so let's get rid of this stuff, and I'll show you how to do this algebraically, right? It's the same way we just did. You are going to have x equals t squared, that's your first equation, y equals t minus 2, and we're going to solve this right here. We're going to solve this for t and put it back into the equation. So t minus 2 goes to t equals y plus 2, right? And it's just like combining functions. Wherever we see t here, instead we're going to put y plus 2. So instead of having t squared, we have y plus 2 squared. And obviously that's going to give us that function back because this is a parabola, but since it's a y parabola, it's going to give us that one. Let me bring it back over here. It's going to give us kind of the sideways parabola, since we're dealing with y instead, which is not a function in this case, because it does not pass the vertical line test. All right?